hello to you all, to those who are near and those who are far. Right, you're back at home now, okay? Maybe home is just in the hostel, but we're back in online learning. And this week, we're basically going to look at still calculating areas and we're going to be calculating surface areas and volume. So if in the last week we looked at two-dimensional shapes that we can draw on a paper, and we calculated the perimeter and the area inside them, now we're looking at 3D shapes, okay? Things that, well, we can draw them on the paper, but really they have a volume, okay? We just draw an approximation of them. So this is an example of what we call a cuboid. Okay, obviously I drew it on the paper, but you understand what I'm saying when it has 3D, okay? It takes a certain volume. And what we're going to calculate is the surface area and the volume of these shapes, okay? Today we're going to look at the surface area. So surface area is, again, if you were to, let's say, paint, you had a little box and you want to paint it with white paint or whatever, okay? The surface area is the area that you paint, okay? And we've done that last year, okay? I think, okay? But it's not a big deal, okay? I think probably the hardest bit here in this whole topic is to be able to draw three-dimensional shapes. So it's worthwhile drawing that. Okay? When I draw a cuboid, which is like a box, I will draw the rectangle, the face of that cuboid, and then I'll draw a line going up like that, and I close it there. You can see that it's 3D. Okay? I think it's a good idea whenever you do an exercise from the book to try and copy the shape, so you will be able to see it in your mind. Okay? So let's say we're told that this is 12 meters, this is 7 meters, and this is 50 centimeters. Okay? And we asked to calculate the surface area. Now, the first thing you need to do is make sure all your units, you're working with the same units. You can't work with centimeters and meters at the same time. So I would personally convert the centimeters to meter. It's just easier because I already have two units with two measurements with meters. So let's just change that. 50 centimeters divided by 100 is going to be 0.5 meters. Okay? Now, how do we calculate the surface area? I'm just going to pause you here for a second. Okay, so I've got a cuboid. This is a cuboid. It's basically a box. Okay? Now, a cuboid or a box have 6 sides, right? It have 1 and 2, okay? The top and the bottom, the front and the back, so that's 4, and 2 on the side, 6. 1, 2, 3, 4, 5, 6. Now, the top and the bottom are identical, right? The top and the bottom are identical. The sides are identical. And the front and the back are also identical. So we have 3 pairs of identical sides. To calculate the surface area, we need to calculate the surface area of the top, the area of the top, and time it by 2 because we have top and bottom. Calculate the area of the front and double it because we also have the same in the back. And calculate the area of one side and double it because we've got 2 of those. So let's do that. Okay? So let's start with the front. The area of the front, I'll paint it in red. The area of the front is 0.5 times 7. Okay? That's the area of the front. Now we said we have 2 of those. Okay? So we're going to time it by 2. We've got the front and the back. Okay? Next. Okay? So I'm calculating SA. SA stands for, not South Africa, it stands for surface area, okay? The area around that 3-dimensional shape, okay? The next bit, let's calculate the sides, okay? Now, if this is 0.5, that's also going to be 0.5. These 2 sides of the rectangle are opposite, so they're equal. So the area of the side, I'm drawing it in blue, is going to be 0.5 times 12, right? 0.5 times 12. Okay? And we said there are 2 of those. There's on the left side and on the right side. You can't see it in that shape because it's only 2-dimensional paper. Okay? Next thing, we've got the top and the bottom. Okay? Okay? So let's calculate the area of the top. Right. I know that this length is 12. That means this length and this length are also 12, right? That and that and that is the same. I'll show you in the real box, okay? So if this was 12, okay, look how I'm showing it to you how it is there, okay? So this is 12, that means this is 12 as well, and this is 12. Okay? They're all the same length. All these are the same length. Just like all these are the same length. Okay? Right? So 12, I need to time that by that number. Okay? To find out the area of the black side, I need to time this length by this length. Now this is 12. What length is this? It's the same as that. So this is 7 as well. Okay. So the area here is 12 times 7. And obviously I need to multiply it by 2 because I have top and bottom. Okay? Right? I'll just calculate. I'll pause you here. Okay, I put it all in the calculator just as it is. And I got 187. Now because I work with meters, every time I'm multiplying meters times meters, meters times meters, meters times meters, the answer will be meters squared. Okay? Surface area has the same unit of area. It's in meters squared or centimeters squared, whatever you work with. Okay? Let's move on to the next question. Okay, our next shape is what we call cube. So if this was a cuboid, which is a box, a cube is basically a cuboid, it's a box, but all the length are the same. Okay? Still have 6 lengths, like just the cuboid, but all the lengths are the same. Now, I just want to show you how I'm actually drawing it. That's how I learned to draw it. So I'm going to draw the square, which is the face, and I'll make a straight line like this. Okay? Okay? Now, let's say each side is 3 meters. Okay? What will be the surface area? Well, think about it. All the sides here are 3. So the area of one surface, the area of one side, is going to be 3 times 3. Okay? Now, how many sides does the cuboid has? Okay? Let's get that cuboid again. Okay? 1, 2, 3, 4, 5, and anyway, 6 sides. That's before. Okay? So we're going to have to count it by 6. 9 times 6. 54, and if I work with meter, it will be 54 meter squared. Okay? Right, let's move on to the next shape. Okay, our next shape is a pyramid or a prism, okay? Or triangular prism, okay? Triangular prism, okay? What is a triangular prism? Okay, this is the nearest that I can find for a triangular prism. So you've got the triangle. Okay, you see the surface, the area of the front is a triangle, not a rectangle or square. Okay, and then you've got, it's made out of 2 triangles, one on either side. Okay, and then you've got another 3 rectangles, 1, 2, and 3. Okay, so that's called the prism. Okay, prism really is the word that we use for shapes that have 2 bases that are equal. Okay, you'll see pyramids, probably not this year. We'll work with pyramids in grade 10 if you do maths. Okay, so this is my first pyramid. Okay. I've got this length is 11, this is 15, this is 10, this is 9, and this height here is 6. How do we calculate the area? Right. So a prism has less shapes, less sides. How many sides does it have? It has the top or the bottom, or front or back, whatever you want to call it, the 2 triangles, okay, plus 1, 2, and 3 rectangles. So what you're going to do is just calculate the area of the triangle, double it, because there's 2 of these identical triangles, and then add the areas of the 3 rectangles. So let's do that, okay? So let's start with the triangle. That's a tough one, okay? So the triangle, turn it blue, is going to be base times height divided by 2. So we're going to do the base is 10 times 6 divided by 2, okay? So that's the area of one triangle. But there's 2 triangles, so we're going to multiply it by 2 because there's 2 triangles. Okay? Next thing, let's look at the area of this rectangle. Okay? Now, what are the lengths? 15 and 11. So the area will be 15 times 11. Okay? Now, here is where it becomes a little bit tricky. You might think, as in this pyramid here, those 2 rectangles are the same. And then you might just be tempted to double that. But in this rectangle, if you look at it, they're not the same. Because the length of this rectangle is 11 and 15. But the length of the rectangle behind, okay, what will be the length? Okay, well, this length is 9 and this length is 15. Okay, so it's going to be 9 and 15. Okay, if I'm drawing the rectangle behind, the one we can't see. Here the lengths are 11 and 15. On the other side, it's 9 and 15. Okay, this is 15, this is also 15. So it's not the same. So the area behind is not plus, I'm adding, plus, let's do another color, okay, plus 9 times 15. Okay, and then we've got the rectangle at the bottom, okay, which is definitely different, even in this example. What are the lengths of the rectangle at the bottom? 10 and 15. So we're going to have to add to that 10 times 15. Okay? Right? I'll pause you here. Right, chaps. Now I just want to go over a couple of examples. I'm not going to solve them completely, but I'm just going to put you in the right way so you'll be able to solve them. They're a little bit more difficult. So this is another triangular prism. But the thing is, okay, we know this is 3, this is 4, this is 7, this is obviously also 7. But we're missing this length. Okay? We're just told that it's x. How are we going to find out the surface area? So we need to obviously find x first. Now here we're using Pythagoras because we also see that this angle is 90 degrees. So this triangle is a 90 degree triangle, and you can find it using Pythagoras. X squared equals 3 squared plus 4 squared, and you might even remember that in this case we get x equals 5. So once you know that this is 5, then you can find out the surface area. Maybe I'll do it one more time just to give you an idea of one. So the area, the surface area, will be the area of this triangle, and we've got 2 of those triangles, so I'm going to write 2. There's 2 triangles. What's the area of this triangle? It's half times the base times the height. The base is 4. What is the height? Well, that's the height. Yeah, remember, when it's a 90 degree triangle, the base is basically one of the sides. So it's 3 times 4. 4 times 3. Now we've got 3 more rectangles to calculate the area. One is that, one is going to be here, and one is going to be at the bottom. So what will be the surface area of this one? It's going to be, this is 7, it will be 7 times 5. What will be the area of the rectangle at the bottom? Is going to be 4 times 7. And what will be the area on the left side here? Well, it's going to be 3 times 7. So I'm not going to calculate for you. I will put this exercise for you to do as work. But this is going to be, you can just put that in a calculator and get the area. One more triangle, okay, which you will find it there. I will give you to that for homework. So they tell you that this is 0,02 meters. They tell you this is 4 centimeters. They tell you that this is here. You can see try and draw it nicely. Okay. They tell you that this is 1,5 centimeter. Okay. And they tell you that this is 3 centimeters. So again, let's start with the area. And one more thing. They tell you that this is 10 millimeters. This one. Okay. Now, so we'll start with calculating the area of the 2 triangles. So the surface area will be the 2 triangle tan. What is the area of this triangle? So the first mess we have here is we've got meters, millimeters, and centimeters. It's all a mess. I would recommend, let's just work with centimeters. So the area of this triangle is going to be the base times the height divided by 2. Okay? What is the base? 0,02 meters, but we're working with centimeters, so we time by 100. Going to be 2 centimeters. What is the height? Okay, so we had a look at finding area of triangles that are not acute triangle. Okay, a triangle with angle which is larger than 90, and we know that the triangle, okay, with an angle which is more than 90, the height is just on the outside. Okay, it's this one, so it's 10 millimeters. Okay, how many centimeters? 10 millimeters, 1 centimeter, and we got to divide by 2. Area equal base times height divided by 2. But we've got 2 triangles. Okay? Then obviously you need to find out the area of this rectangle, the bottom, and the one on the left, and I'll let you do that. We've done already a couple. Okay, I'll pause here and we'll do one more example. Okay, so the last question I'm gonna do actually for you is B in page 242, and they give us a cube, just like that. And you know that the sides, all the sides are only 14 centimeters. Now the first thing they ask us, what is the surface area of the whole cube? Okay, so we know the area of one side is 14 square. Each one of these squares, each one of the squares have an area of 14 square. Okay, but now how many squares, how many colors I've got here around this cube? The answer we already mentioned before is 6. So the total surface area is going to be 6. Okay, now this when it's all closed. Okay, but now they're asking us to calculate the surface area where the top is open. In other words, we open this, we are missing this one side. There's one side of the top that we're missing. We don't need to paint it, let's say, okay, because it's open. So it's open. Okay, what will be the surface area now? Well, the area of each square is still 14 square. Now, how many sides are there now? Correct, only 5. Okay? Right, guys, I solved a lot of examples for you. Now it's your turn. I'm going to give you a bunch of work from this exercise 2. Enjoy, and please send me any questions on the WhatsApp.